a moment. So the outline for our session today, basically I'm going to start with a description of SMP, which is Streetmap Premium. I'll talk about what data sets come with it and how you would obtain access. We'll talk about geocoding and what that process means, and then network analysis. The network analyst extension is part of ArcGIS Pro and ArcGIS Desktop. It allows you to use street connectivity and distance along a network for analysis, and we'll go over 3 of those common types of network analysis today. After I complete the slideshow, I'll go into a demo where I'm going to show you how to use Streetmap Premium to perform geocoding. We'll talk about properly formatting an address table, setting up the operation, and then what you would do to review and rematch addresses if necessary after you've run one of those analyses. And then I'll demonstrate 3 types of network analysis with Streetmap Premium. We'll do a routing exercise, a service area, and a closest facility. Now, first of all, let's talk a little bit about Streetmap Premium. Streetmap Premium is it's a premium service or subscription that ESRI offers on top of the site license that we normally pay for. And so this is an added service that we have purchased for the university, and it gives us access to a very detailed road data set that is optimized for 3 different things. First of all, for mapping and routing, and then logistics analysis. Those are the 3 types of functions that we can do with these data. Now, the mapping process, the data set includes a rich set of street features and ancillary coverages like land use, hydrography, building footprints, and so forth. And this is the spatial extent of our subscription is North America. So we have Mexico, the United States, and Canada included in that those sets of features. And so these features are available for your use in just providing context to your normal maps. And some people might use the data for that. We do have a limited number of seats. And so typically I would recommend, if people are just looking for adding features like these to their maps for context, I would recommend the ESRI base maps as a much better option, because you don't have the same data management footprint or steps involved as you would with the Streetmap Premium product, which involves quite a bit of data wrangling in order to get this data available for your use on the local system. Let's see. The next item up for bid is geocoding. This is the process where we take a table of locational information. Usually this comes in the form of street addresses, 123 Main Street, St. Louis, Missouri, 63130, for instance, and a table of information like that, which is stored either in Excel or CSV format, can be imported into ArcGIS Desktop or ArcGIS Pro, and then run against an address locator that is part of the Streetmap Premium product. That allows us to convert those textual addresses into coordinates and then add points to our maps. And this is a great way to take survey data, for instance, or data that's come from a different source, and convert those tabular features or tabular records into spatial features that can be then used for further analysis. And then the final type of analysis that we can use with Streetmap Premium is excuse me, routing. And the network data set that comes with Streetmap Premium can be used for simple point-to-point routing, also for more complex delivery logistics, but we can also do more complex network analysis tasks like closest facility or responder. In other words, who would be able to arrive at a call faster. Police, fire, and ambulance services would use this type of an analysis to determine which of their remote or fixed facilities could actually arrive at a call the fastest. And then we can also do service area analysis. This allows us to define an accessible area within either distance or time constraints. And those polygon features basically define areas whereby, in many cases, this might be of interest to a business. Maybe Starbucks wants to find out what are the demographics of people that live within a 5-mile or 5-minute drive or walk time from each one of their stores. And so the service area analysis would generate that polygon and then allow the business to perform further analysis on finding out who lives in those areas and maybe defining some strategies as to how they might reach them. So the next question we usually get is, how do we obtain access to Streetmap Premium? We have a GIS research guide for that, and the link will be in the slides. The key thing to remember about the Streetmap Premium product is this is a very large data set. It's going to require 40 to 50 gigabytes of space on your hard drive for you to download and install that resource. And for that reason, we're not going to be able to actually physically work with this today in this session. I'll be doing some demonstrations and showing you the data set and how it is used, but I won't be able to guide you through the process of working along with me. We are in the process of installing the Streetmap Premium product into the Research Studio. And once that happens, you'll be able to remotely log into a system. There will be no overhead of trying to install a data set and manage to keep it up to date. You'll be able to log in, open up one of the applications, whether it's desktop or pro, on those systems, and then run your analysis. The thing with Streetmap Premium is we have a limited number of seats, and so we have to maintain a bit of control over how many people gain access to it. And so many times our researchers will utilize this resource on a temporary basis. At the beginning of a project, maybe they've got several thousand addresses they need to geocode, and they want to use the latest and most up-to-date data set in order to do that. Streetmap Premium provides that option, and the researcher would actually not need access to that data set for long. They would geocode their table, create a set of point features, and then those features would then could then be exported and used for further analysis without need of having access to the Streetmap Premium product. And so in that case, the researcher would have temporary access, and then we would be able to assign that license to somebody else who might need it. And this is a remote desktop system where I have installed Streetmap Premium locally, and I'm going to use this environment and this platform for the demonstration today. So the first thing I want to do is talk a little bit about mapping with Streetmap Premium. And I'm going to minimize my file manager here and open up ArcGIS Pro. Now, we had 2 sessions earlier this week on ArcGIS Pro, and so I'm not going to dwell very much on the simple usage of the platform. If you have questions along the way about what I've been doing or how I'm handling some sort of process, please stop me and let me know. But for now, I'm going to go ahead and open up a blank map, and I'm going to set this project up, and I'm going to call it SMP Demo. And I'm going to set this up in a folder on my desktop. I have one, strangely enough, called SMP Demo. And I'm going to avoid setting up a second folder inside that project. So ArcGIS Pro is opening now with my, my map window, and you'll have to excuse me. My system is a little bit slow to refresh. So I'm going to try and close this off and open the project up again. Okay, it doesn't look like that open, so bear with me just a moment. I think I might have been in the wrong folder. As you can see, I've got a few too many folders on my desktop. Organization is a quality I'm still learning. Okay, so ArcGIS Pro is open. I want to show you a couple of things. First of all, in the folders, I'm going to make a connection to the folder which contains the Streetmap Premium product. When you will, and if you install this on a local system, you will actually control what folder this data sets go into. And I've got a couple of versions of this data set stored on my system. But the thing I wanted to point out is a couple of things. First of all, the Streetmap Premium product has three different, or at least in this year, there are three different revisions of the data set. So on a regular basis, ESRI publishes a new version of this data set with updates since the last version. And so far we're up to 3 versions for this year. The demonstration I'm going to do today is going to use this, the first one that came out this year. But there are 2 major products that come with the Streetmap Premium product. One is a file geodatabase here called NorthAmerica.gdb. This contains all of the standard features that are used in the data set. And the one that we're going to be working with today is basically this routing feature data set, which allows us to use a network data set called routing_ND, which is made up of several different feature sets. I also wanted to point out that it ships with a map document called NorthAmerica.mxd. This is basically ESRI's default version of the map, and I'm going to go ahead and load that now. So I'm going to insert and import a map. And I'm browsing into Streetmap Premium to find the MXD file. And I'm going to load that map into the project. So ESRI is providing this map document so that we can easily see the product and look at the features in a curated fashion. And they've set up a series of scale-dependent layers that display information that's pertinent to the particular viewing scale that you're looking at. And I'll show you exactly what that means as soon as this map imports. Okay, so now we see North America and some of the features begin to appear. You can see in the contents pane a series of group layers, and I'm just going to expand one of them at random. This is designed to be from 750K to 300K as far as the display scale. And so that I'm going to right click and zoom to this layer, or zoom to this view so that it's visible. And so that's going to zoom us into the 1 to 750,000 scale range. And I'm going to zoom back out so I can find myself. There we go. Okay, let's just zoom into 500K. And so you can see some of the features here. We see some land use designations. We see state boundaries. We see some major highways and things like that. If we continue to zoom in, and I'm just going to use the incremental zoom in tool just to zoom in a little bit further. As we zoom in closer, we're seeing more and more detailed features. And this is due to that scale dependency. Now, I'm not in an urban area, so it's likely I'm not seeing some of the more interesting features that we might see in an urban scale. Let me get to a more appropriate space. San Francisco sounds good. And so this will demonstrate a little bit more effectively the types of features that we see as we begin to move in closer. And you'll notice in the table of contents, as we change our zoom scale, the layer that is appropriate for that scale is being actively shown, whereas all the other layers are showing up with a gray box, indicating that those are not visible right now. This shows the scale dependency of this particular layer, and this is how they've set this up so that we can more effectively use these features. It only shows us features at the scale range that would be appropriate to visualize at that scale. And as we get in closer and closer, we begin to see much more detail as far as the labeling, the road features, and at some point we begin to see building footprints and things like that. So the data set itself contains quite a number of detailed data sets that can be used for cartography. So we could symbolize them. First of all, we could use them in their current state using the default symbology that ESRI has provided, or we can simply bring those features in and symbolize them on our own. So if a user has specific cartographic needs, this would be an option that would be appropriate for them. Okay, any questions regarding cartographic use of this data set?
Hey, Bill, I have a question.
Yeah, Molly.
It looks like there's no base map. Are all those features, or is there a base map?
Let's see, I think there is not a base map. There's a water background and land, but there is no formal base map feature like you have when we normally look at these map documents.
Okay, cool.
I'm
Thanks.
pretty sure, let me make sure. Yeah, so there is no base map layer here. And so everything that you see is part of that Streetmap Premium product.
Okay, cool. Thank you.
You're welcome. Okay, I am going to come back to familiar territory. And so the next thing I want to talk about is geocoding. So as I said before, this is converting address information into spatial coordinates and is basically one of the primary uses of the Streetmap Premium product. Now, if you were paying attention when I showed you my example here, let me go into the data folder. The Streetmap Premium product actually comes with two types of locators. We have classic locators and we have new locators. Very clever naming scheme here. The classic locators actually only work with ArcGIS Desktop. And so these are locators in the older format that ESRI originally developed for using address locators. These are functional in the desktop version of the software, but they're being phased out in 2021. And so at some point next year, we're going to stop getting the classic locators. And the only locators we will be getting will be these new locators that actually work with ArcGIS Pro. And so these are optimized for for the application. I'm not really sure what the difference is, but these will not work in ArcGIS Desktop. And so the only game in town is to play with these in Pro. Now, the locator is basically a large database that is used to match an address with coordinates on the ground. And we're going to see how that process plays out right now. So the first thing I want to do is I'm going to add some data to the map, or add some data to my project so that I can perform this function. Now, I don't need the Streetmap Premium full data product in order to handle this example. So I'm going to close this map now, and I'm going to zoom into St. Louis here. And I'm just going to get to familiar territory here around Forest Park. Now, I have a table of data that I'm going to use for this demonstration, and I have that. I will share that with everybody at the end of the session as well. But the table I've got is a set of Missouri hospital addresses. So I'm just going to drag and drop that data set into my map, and then I'm going to have a look at it so that you guys can see what these attributes look like. So this, the data set has a hospital name column. It's got a couple of full address and trimmed address columns that basically contain the entire address that as you would normally see. It includes the street address, the city, the state, and the zip code, and in this case, a 4-digit zip code extension. Both the full address and trimmed address give you that, but I've also parsed that address out into an address column, city, state, and zip, and then I've also got a state and zip column out at the end all by themselves as well. So Streetmap Premium will actually geocode either with a non-parsed address like the full address and the trimmed address columns, or with a parsed address. And I'm going to show you an example today of using that parsed address. But keep in mind that cleaning your addresses may not be as important as it used to be when you're working with the Streetmap Premium product. Let me minimize this table just a bit. And then to start the geocoding operation, you just right click on the table, and there's an option here in the contextual menu to geocode the table. Now that's going to open up a guided workflow. This geocode table panel appears, and it gives you an overview of the operation and the steps you're going to go through as you build up this geocoding process. There's a start button down here at the lower right, so we'll just accept that and get going. First, it needs to know some information about our table. The input table is already provided because I initiated the process from the table in the contents pane. Now, I also have the choice of determining whether I want to use a single field or more than one field for this operation. And I'll demonstrate this parsed option today. So click next to continue. Input locator, I need to utilize the address locator that comes with Streetmap Premium. As a default, because I am logged into my ArcGIS Online account, I have access to the World Geocoding Service, but I don't want to use that. So I need to browse to the network data set that I'm going to be using, or actually to the address locator that I'm going to be using for this process. So the browse button will allow me to go into my folder, and I'm just going to select the North American.loc, which is the address locator for the United States. Click next to continue. And now this is the panel where you map the address fields in your incoming data set to the data, or to the locator field that is going to be utilized by the address locator. So there are certain common names that the locator will look for. And so that's why it's populated automatically, the data field for address, city, state, and zip. Now, if for whatever reason I had a different name for my address field, you can just simply use the drop-down menu. It gives you a full list of all the attributes in my table, and I could select a different one if I wanted to. These are all populated just fine. So I'm going to scroll down to the bottom and click next. And then I need to specify a place for the output. My output is automatically taking the name of the input table and appending _ geocoded to it. It's also going to automatically place this in the geodatabase that's associated with the project that I created. And so there's a default geodatabase there in my databases folder. That SMP _ demo was already created. That's the place it's going to automatically put it. ArcGIS Pro tends to handle output data a little bit better than desktop used to do, but it's always a good idea to make sure you know exactly where your data is going to go. The other thing I'll mention that's different between Pro and the desktop version for these geocoding operations is when we added geocoded data in desktop, it basically created a temporary data set that was associated with the map document. In ArcGIS Pro, it's actually creating an output data set that's stored in the geodatabase and would be accessible to projects outside of this one. So I'm just going to cancel this. Then I have an option for the location type that I prefer from these addresses. And there are two options here: address location and routing location. The difference being an address location will geocode to the most specific information that the data set has. And that would be sometimes building footprints, sometimes point locations, sometimes centroids of parcels. And so the address location is typically going to be offset from the roadway. And sometimes that's advantageous because you're trying to identify a home or something like that, and you're not necessarily interested in identifying a point on the street. And that's what routing location will do. So this uses the street features that are part of the Streetmap Premium product and geocodes exactly to a point on that street. And this is advantageous when you're doing routing analysis because sometimes points that are located off of the network will not necessarily associate with the network in the way that you might anticipate. It depends on where that point location is in relation to the street feature that it would reside on or other nearby street features, and it can be confusing. So routing location is a good one to use if you know you're going to be doing some routing analysis. And I know we want to use this, or I want to use this later in the example to do some network analysis. And so I'm going to use the routing location option. So I'll click next here. And now we have a couple of limitation options. The step 5 and step 6 are about that. First of all, we're going to limit by location. So we can specify the country in which our addresses occur. For us, most of our addresses are going to be in this case, either in the United States, Canada, or Mexico because of the spatial extent of this source data. But if we had locations in other places and a data set that would allow us to geocode there, we may want to more carefully limit that setup. Now, in the next panel, step 6, we can limit by category. And I'm going to expand the address category here just to point out that there are several different types of addresses that we can use this product for. A point address, street address, those are fairly familiar. Distance marker would be a mile marker on an interstate or something like that. And frankly, I have not worked with this option yet, so I'm not exactly sure what the syntax for geocoding those types of locations would be. I do know about geocoding intersections. This is something that we used to do with older ArcMap data sets. And so the intersection basically just gives two cross streets, a primary and a secondary, and we'll basically geocode the intersection of those two features. But There are other categories as well: postal, coordinate system, populated place. If, for instance, you were going to be geocoding neighborhood data, and that's the kind of information that you had, then you could limit your geocoding to that particular type of matches, and by doing so, you will make the process a lot more efficient. You know, when you're dealing with several thousand addresses, it's probably temporally isn't going to make that much difference. But if you're dealing with 50,000, 100,000, a million addresses, specifying the type of address you're trying to match is going to facilitate the process and keep the system from having to look at many different options and just focus in on the things that are most important. And I'm just going to use the whole address category here, and then we'll click finish. And now the system provides us with a summary showing the choices that we made. And I'm just going to zoom down here to the bottom, and we'll click run. And I'm going to pull it down a little bit farther. We get a little process progress bar here showing us what's going on. And then we should get a successful completion and a splash message that shows us we had 145 matches, no unmatched records, and 8 tied records. That's kind of interesting because when I was prepping this for my session, I was always getting 1 unmatched address. So I'm not exactly sure what happened since the last time I ran this data set, but now I'm getting 0 unmatched addresses. That's kind of interesting. So it's added that layer to my map. I've got a Mo Hospitals geocoded layer in the contents pane, and it's offering me the option to start the rematch process. If, for instance, I knew that I had a lot of unmatched addresses that I wanted to fight for immediately, then I would just say yes here and go ahead with that process. I'm going to show you how to get back to this process in a different manner. So I'll close this right now. And so I'm going to zoom in to the St. Louis region and get around to Forest Park again. This is kind of a familiar area to those of us at Washington University. And so I just wanted to pop in, and I'm going to go ahead and change the geocoding symbology here just to boost the size of that point a little bit. So we can see those better. So now I have the results from this operation. I'm going to push up my table here a little bit so we can see. This table is fairly basic. It includes several, it includes all of my input columns, but there are just a few of those columns. We have less than 15 columns in this table. Now I want to show you the output table from the geocoded version. And that includes quite a few extra columns. And I'm just going to scroll far to the right here just to show you that, yeah, there's a lot of columns in this output file. The original columns all reside out here in the far right end of the table. So zip, state and zip, all of those things are the standard fields that came with my input data set. And then all of the other columns that you see in this feature class are associated with the geocoding operation. And some of them are designed to hold the address that's being geocoded. So it makes a copy of my input file, stores it in a new set of columns so that it can geocode those, and we can use those fields for some data correction. And I'll talk about that in a moment. Over here on the far left, when you open the table, you'll see a couple of columns of interest, and that is the status column and the match type column. These 2 columns give you information on whether the records were matched, tied, or unmatched with an M, a T, or a U, and then also the type of match that was accomplished. And there's several different types here: address matches, point matches, and then we can also do some manual matching ourselves. And I'll talk about that when we do the review and rematch operation. So anyway, I'm going to set a bookmark here real quick. so I can find this later. And then I'm just going to zoom out to the layer. It's full on hospitals here in Missouri, and I've got a set of hospitals that cover the entire state, and I don't have anything hanging out outside the boundaries or out in the middle of the ocean or something like that. So I'm pretty confident that I got good results from these addresses. And I'm just going to pause here for a second. Does anybody have questions about the geocoding process? Okay, so let's keep going. So when you process a set of addresses, the kind of success rate that you get depends on the methodology that you're using and how critical it is for you to match, say, a point address. Many of the address locators that we use, and Streetmap Premium is like that, will cascade. In other words, if it doesn't find an address match at the lowest possible level, which will be the street or building address, it will default up to a higher level. Maybe it's looking along a street segment and it just finds the centroid of that street line because it lacks some addressing information, or it doesn't have a good match. If that doesn't work, it goes even higher. Sometimes you'll end up with a match at the zip code level or the county or even city level. And those would be points that appear on your map, but don't necessarily map to a particular address. And so it is important to take advantage of this match type option to see whether or not you have any records that that don't correspond to an address match. And I'm just scrolling through this table. I don't believe I have any in this example that correspond to something that would have fallen up to a zip code, but we can look at some of those options in the review rematch option. Okay, so a success rate like the one that I just got, where 100% of my input records were assigned to a good address, that's actually pretty rare. In many cases, you'll have addresses that have typos or other issues that will cause them to not create a good match. And so many times you'll have to go in and fight for accurate addresses for some of your records. And in order to do that, you just right click on the layer in the contents pane. And in the contextual menu, go down to data and then rematch addresses. So this is the same place that we're going to go if we had made that selection in that initial in the initial results panel that popped up. I'm just closing my catalog and my contents panes so that I can get a little more real estate here on the screen. And you can see I've got a panel over here on the right that shows me my matched or tied addresses. If I had any unmatched addresses, I'd also have an option up here for unmatched. And so you just activate whichever one list you want to look at. It's going to show you the number of records in that list. And in this case, it's showing me the first record, this hospital in Columbia, Missouri. And in the display panel, I can see that it's showing me the candidate locations and the one that it's selected, which is this A option, and it's highlighted here in the map. So this one, the type field here is showing me that I've got street name for two options, the A and B option. And if I click on B, it's going to turn out that it's a slightly different location down the road. I'm just going to zoom a little bit over here so I can see all three of those values. And then postal, which is actually this C option, appears to be aligning with a mailing address that has a better spatial location than the street addresses that were used to generate these. So the default selection here is this hospital drive, the first record, but the one I actually want to use is this third record, which is C. And so I'm going to highlight that, and then I'm going to match that using the checkbox here on the upper screen. So I match that, And now it's basically assigned that as a match, and then it's reduced the number of tied records that I had down to 7, and it's showing me the next record. And so this sort of process is what you would go through to fight for individual addresses to make sure that you're getting the right, you're getting the most out of your data set. So I'm just going to page through a couple of these. In some cases, we've got you know, the same issue. We've got several street addresses or street names that match. This one was US 60 Mountain View, Missouri, so it doesn't have much in the way of information here. There's no there's no street number or anything like that, but maybe I want to try and fight for this one. So I'm going to zoom out a little bit in my window here and just see if I can find something that looks like a hospital here in Mountain View. And for the sake of argument, I'm going to just select this large building here and zoom in there. Oops, wrong way, Feldman. And so let's, for the sake of this exercise, let's assume that this is the hospital that I wanted to identify. And I don't have a good address for it, but I know this is the place that I want to have represent this record in my data set. So I can pick from the map. There's an option here on the toolbar at the top of the table. And if you just select that, it will change my icon. You got to wait for a moment, but your cursor icon is going to change into an icon to indicate that you can pick a point from the map. And in fact, it has changed underneath my arrow, but I'm not seeing that at a good scale here. It basically has a different symbology, but I'm going to mouse over this building that I'm going to use to identify or as a stand-in for our hospital, and just click once to set that point. Now you'll see in my address table here, it's added this PP symbol, and it's identified this as a map point as the type of match here. I'm going to highlight it and go ahead and match it. And so that's going to add the point into my data set as a matched address, not a tied address. And then I could go through and continue this type of process. But I think you get the idea here. There are various ways to correct the errors. And actually one other one I wanted to mention, the address itself can sometimes have errors. So I'm just going to scroll through this one here for a moment. This one has a full address in the upper result, but let's say for the sake of argument that the city of Belton was misspelled or the zip code had an error, and I noticed that while I was doing this this analysis. If that is the case and I want to try fixing something, maybe my zip code happened to be missing the last digit and it should be a 2. So I'm going to retry this. I'm going to tab off of that field. I'm going to apply this. And so it's going to try and find that again without having the actual zip code. And the match address already has a zip code in it. So I'm assuming that that's not going to allow me to show the error. But the point I want to make here is that I can make corrections into the address in these fields. It doesn't change my original data. This goes back to the idea that we had all those extra columns added into the geocoded data set. Those are used to, provide a temporary house for the attribute values that they use for geocoding. And so I can make changes here to correct issues that I notice, and then I can, of course, apply that again, and I'll generate a better address here. And then I can, of course, select that and make it the one I want. And so because this is tied, it's already assumed that this is an actual good address. And so it's not going to take that one away from my list. At any rate, are there any questions with corrections to or the rematching operation for addresses? I'm just going to pause here for a second. Okay, hearing nothing, I'm going to keep moving. So I'm going to close my rematch addresses operation. I'm going to expand my contents again. And I'm just going to go ahead and use my bookmark to get back to Forest Park. Okay. So let me consult my notes here briefly. I believe I've come through the geocoding and the reviewing and rematching of addresses. And so now we're down to network analysis. And network analysis is basically the idea that we want to take advantage of a connected set of spatial features representing roads and nodes that connect those roads. And that network data set is going to allow us to define paths between different locations to define, say, the shortest path based on distance. We can also include in that analysis, maybe we were interested in the shortest path time-wise. That may not be the same as the shortest distance path. And so depending on the attributes that are associated with our road features, our network data set can allow us to perform some fairly complex routing analysis. Okay, so there's a first off, I want to, in my catalog tab, I want to show you what the street network data set looks like. So I'm going to minimize some of this excess stuff here. And I'm coming down to the North America.gdb. And there's a couple of things I want to bring in. First, in this routing feature data set, I've got a routing network data set. And if you're not familiar, the feature data set combines feature classes that have the same geometric coordinate system. And in this case, those feature classes have been combined to create the routing network data set. And so you can see here, we've got streets, we've got junctions, which are points, we've got restricted turns, which are lines, and then we've got signposts, those are also line features. And then we've got this routing streets override, which are also point features. So I'm going to bring several of these into the map and show you what they look like. So first we'll bring the routing network data set in. And this is going to add those features that participate in that data set. And ESRI has applied a default symbology to this layer. So I'm going to expand this in my contents panel. I'm going to go ahead and close this geocoded table so we can gain back some of this real estate here at the bottom. See if I can close that. Okay, let's go back to Forest Park. And so now you can see the symbology that's shown is based on traffic pattern data sets. So based on the time of day and the day of the week, they have a set of historical traffic flow data that's used to define what the type of traffic flow I could expect on these particular street segments, stop and go, slow, moderate, or free flow. And that is based on this historical data set, and that data can be used as part of our analysis to try and model, well, what's the delivery path going to look like in the middle of rush hour traffic? It's going to certainly be a lot slower time-wise. Distance will probably not matter, but it may even, in fact, impact the direction that we take connecting to particular locations. And so this basically represents many of the features. Now you'll notice in Forest Park, I'm not seeing all of the features. The features that I'm seeing here, these white roads, are part of my topographic base map, which is automatically included in my map. And if I turn that off, you'll see there are some roads missing from this symbolization of the data set. And so I want to go back to my catalog, and I'm going to bring in the routing streets, and then I'm also going to bring in a couple of the node features so that we can look at those a little bit more closely. So I'll bring in the network dataset junctions and the routing streets override. And then I'm just going to zoom into a section of the park here so we can have a little bit better look at these. So the street segments are all linear features. And when street segments when they come together, they have to have a node defined either at endpoints of the roads or at places where a couple of different street segments come together. And I didn't get my override in there, I don't think. I'm going to check. Yeah, my override nodes didn't come in. I'm going to bring that in. So there's two different types of nodes defined for this data set. The standard routing ND junctions data set basically shows where roads are connected, and in most cases that's anytime a couple of roads come together at a location. Sometimes that happens along a roadway where two different segments come together, and then in other cases we're looking at these routing streets override nodes. These are defined for places where a street actually continues through a node, and so they've created these special nodes that allow us to define the connectivity at those points as well. The bottom line is the nodes are what allows us to make turns at these locations. It allows the system to understand when two road features that happen to cross or meet, what can I do at that location? Can I turn left, right, or go straight, or all three? And so the nodes allow us to make those sorts, or allow the data set to formalize those types of operations. And that's basically where we get the power of the network data set. So these are basically the building blocks of the network data set itself. I'm going to close the junctions off just so we don't have to look at those. And I'm also going to close off the traffic pattern and just leave us the street network so we can view that. Let's get back to the Forest Park area. And so the first network analysis operation that I want to demonstrate for you is the simple routing operation. And I'm just going to minimize the street symbology here just a bit, so it's a little less obtrusive. And I'm going to minimize my catalog. Okay, so I've got these hospitals that are located around the Forest Park area. Perhaps I'm a delivery service and I need to deliver PPE to each one of these hospitals. I want to find a route that will allow me to connect the dots basically in a fairly efficient fashion. So in ArcGIS Pro, this is accomplished using the analysis toolbar and then the network analyst dropdown. Now this is an extension that should be it should be activated in your ArcGIS Pro license. The first thing to note is that our network data source is showing up down here, the routing network data set. This is because I've got it loaded into my map. If I didn't have the data set loaded, I could still utilize it for my analysis. I would just have to change the network data source and point to the location where that network data set is stored. But since it's already in, I can just go ahead and perform the analyses. You can see here there are 6 different types of standard network analysis that occurs. We're going to go through the first 3 here: routing, closest facility, and service area. So let's start with a route. Click on route, and it runs through the make route analysis layer tool. And this is going to add a group layer to our contents tab that includes stops, routes, point barriers, line barriers, and polygon barriers. And in fact, it's also appears to have added 9 stops, which would have been the stops that were visible in my screen here. I'm going to shut off the history layer. And I'm going to right click on stops and open up this attribute table. And I'm not exactly sure why this is showing 9 stops here, because I don't have anything in my table and we haven't done the loading process. So I was a little bit surprised to see that, but I'll show you how to load features into the stops feature class. Let's minimize this a bit. And let's go back to Forest Park again. I think might have some features selected in the hospitals. So I'm going to make sure I don't have anything selected. And I'm going to activate my selection here. I want to make a selection from this geocoded layer. So I'm going to make sure that that's the only layer that I can select things from. I want to turn off these features that are participating in my network data set, but I only want my hospitals geocoded to be the option for selection. Then I'm just going to use the select tool and drag a box around these items. So now I've got a selected set of hospitals. 8 of them have been selected. I'm going to go back to the analysis toolbar and the route network analyst toolbar. This ribbon includes all of the settings that I can control in the routing analysis. And the first thing I need to do is import my stops. So I'm going to use this import stops option. It runs the add location tool. And then I'm going to import to the route analysis layer. You can have several analysis layers open in the same map document. The sublayer I want to load is stops, and then the input location, I'm going to select Missouri Hospitals Geocoded. And this is going to honor the selected set that I have already applied here to this layer, and it's not going to load in all of the hospitals that are in that data set. Now, the field mappings option allows me to connect attributes in my input table with attributes that are going to be stored as part of the output. And I'm just going to basically leave these as default, and none of the field names are assigned because I don't really have anything in here that I need to capture with the particular property of this output. So I'll leave the field mapping alone. The search tolerance down here allows you to account for points that are not exactly located on your route. For us, we don't likely have any of those because when we geocoded, we actually geocoded to the route anyway. And so the search tolerance is a bit of an unnecessary setting here, but I'm going to leave it as is. And then I'm going to go ahead and click run to load these points into the stops feature class in my route analysis layer. And the results flashed up pretty quickly. Let me load those again. This window basically reports what happened during the tool. As long as you get a green check mark, you can pretty much assume that things are fine. But if you needed to investigate an error, or you wanted to look more deeply at exactly what happened and how, this view details option will pop that window up for you. I'm going to minimize that and close this out. And so now in my stops layer, I'm going to turn off my hospitals geocoded. They are no longer going to be displayed. And the reason I'm seeing those features now is because they're part of my stops layer. And let me refresh my view here. Okay, it's going to make a liar out of me. Let me go back here. Actually, I was in the selection menu, and so I hadn't actually turned off these layers yet. I'm going to turn off the hospitals geocoded, and now we'll see I've got my 8 stops. I'm looking at the stops table down here. I'm going to expand this a little bit. You can see there are numbers on each one of these point locations. That's based on the sequence in the table. So it runs from top to bottom, 1 through 8, and that's the sequence in which this routing process is going to occur, at least the way I've got it set up right now. And so I just wanted to go through on this route ribbon. There are several different ways that we can control this operation. First of all, we can control whether or not we're doing a drive time, a truck time, a walking distance, or time. All of those options are various modes of analysis for the route process here. And so we'll just continue on with driving time because I'm modeling a a delivery function. You may have noticed when I mouse over drive time, I get information here about what this travel mode means. Normally, in this case, the type would be automobile. Models are movements of cars and other similar automobiles. So you can get more information about what the system is doing by using these little pop-up tips that occur. So I'll keep driving time here for the moment. Sequence, it's set by default to use the current sequence in my table. If I expand this, I'll see that there are various other options I could use here. For this particular example, I'm going to use current, and we'll come back to this in a moment. We're not using time, although I could apply depart date and time, and I could also apply the traffic pattern as well. We're going to define a route along the network. I could also generate no lines or straight lines connecting the various options, but I want to generate routes that basically follow the network. And those are the settings that we can deal with. There are ways to control the accumulation of cost attributes. And this little drop down here with the summation symbol lets you choose which attributes are going to be accumulated. Right now, our distance, let's go ahead and activate miles. And for time, we're going to activate minutes and travel time. And then we'll go ahead and leave those selected. And then once you're ready to run, you can just click the run button on the left-hand side of that ribbon. And that process is going to crank away. And I'm just going to move over a little bit here, right-click my route and zoom to that layer. And now we can see I've got a rather convoluted path. If we zoom in an even closer amount, you'll see that there are several trips up and down the highway here to get all of these sites, to visit all of these sites in the order that they were given to us in the table, which of course is not exactly the most efficient way to visit those things. I'm going to open up the routes attribute table. And this has generated a single route for this set of stops. So I'm going to mouse over to the right here in my table. This is a 15-mile set of paths, and the travel time was about 40 minutes. So that's a fairly large amount of time, and certainly 15 miles distance is a lot of distance to travel to connect those specific dots. So let's go back to Forest Park again, and I'm going to go back to my route in the Network Analyst route ribbon. And instead of now using current, I'm going to rerun this analysis and I'm going to find the best sequence. So we'll let the system decide in what order I should go to most efficiently visit all of these hospitals. So let's run that. And now we get a different route. It looks much more efficient. We're starting out here at one end of the path and basically following along till we end up at the other end at the top. And I'm going to minimize this time button here. Sorry about that. There we go. So looking at the table, I notice my total miles has dropped to 6.6 and my travel time down to about 22 minutes. So I've saved a lot of time and a lot of distance by allowing the system to optimize that route for me. Okay, I'm going to pause for a second. Anybody got questions? Okay, excellent. All right, one analysis down, 2 to go. So routing is great. I'm going to minimize this route layer here. I'm going to turn off the route. And I'm going to minimize this just to simplify my contents panel a bit. Things are dragging a bit. So let's revisit the analysis toolbar and the network analyst. And now let's go ahead and generate some service areas. So I'll activate that tool. It's going to run the service area analysis layer creation tool. And that's going to add yet another group layer to my contents pane. This one includes facilities, polygons, lines, point, line, and polygon barriers. Now, as a brief aside here, the barriers that you see in the route and in the service area, these are features that could be used to model changes in a path. Let's say, for instance, we were going to run a marathon in Forest Park and we were going to close off several of the roads. I would use point or line or even polygon barriers to define the regions that I wanted to close off, add those features into the analysis layer. And then when the routing occurred or the service areas were generated, it would take into account the idea that we would not be able to travel on those paths. If we have some time here at the end, I will demonstrate one of those for you. But let's stick with the service area idea. And so for this, I'm going to turn my hospitals back on. And I'm just going to use the selection tool to select one of the hospitals here. And I have to activate the tool, utilize it. And let me make sure I can select this layer. There we go. Okay, so now I have a single feature selected, and that's because I want to demonstrate the service areas without having too much conflict between the neighboring hospitals. So I'm going to go back to my analysis ribbon, and actually I'm going to click on service area in the contents pane, and that should then reveal at the top of my menu bar my service area ribbon tool. And this gives me the same type of thing that I had with my route. I've got all of the controls for this particular analysis here. So first thing I'm going to do is I'll import my facilities. This is a familiar process. I'm going to use the input locations from the Mo Hospitals Geocoded. This will bring in that single layer. And then I'll just run that to bring in that single point as the only facility in the data set. Let's turn off the hospitals. Now I've got my single facility. Now I can set up the analysis based on several of these options. First of all, let's stick with, well, let's actually go with walking distance. That'll be an interesting an interesting analysis. Let's say I'm in the hospital and I've just got to get out for a walk, and so I want to clear my head. Let's say I want to travel between 1, 5, and 10 minutes. And so I'm going to change my cutoff values here. The default is 1, 2, and 5. I'm just going to backspace here, replace the 2 with a 5, comma, space, and 10. So this will give me 1, 5, and 10-minute walking polygons from the facility. So my direction here is defined as away from the facility. I could also define this as to the facility. When you're dealing with a walking distance like this, whether you're going to or from the facility isn't going to make much difference. But if you were doing a driving analysis, that would take into account one-way streets, and it may, in fact, have a bearing on the results that you generate. So we are also, since we're generating walking distance, kilometers is the default here. I'm going to get that value. I won't use the date and time. As far as the items that I generate from this analysis, I can either select a polygon to represent the area with which in which I could gain access to in those certain amount of times. I could also define the road segments that I could traverse, and then I could also do both. And I'm just going to select that so we get polygons and lines from this analysis. Now there are other options here, like the precision of the polygon detail level, whether or not the polygons would overlap if I've got neighboring features whose polygons tend to extend into each other. And then I can also determine whether I want to generate rings that go from the minimum to the maximum for each element of the range. For instance, from 0 to 1 minute, from 1 to 5 minutes, and from 5 to 10 minutes. Or do I want to generate disks, which would go from 0 to 1, from 0 to 5, and 0 to 10. And so those are two options there. And so I'll refer you to the network analysis support page that defines a lot of these options in a lot more detail and is basically beyond the scope of this exercise today. So we've got our single imported facility. I've set up my analyses the way I want, and I'm just going to click run to get that going. Okay, my solve completed. My system seems to be lagging in time here. It's getting late in the afternoon. Perhaps it's a little tired. So I'm going to close this. I think I was anticipating this cutoff would be time-based, and it's actually, I selected walking distance, and so it's using kilometers. You might imagine that this would be a fairly large set of polygons to generate in a 1-minute walk, but I'm going to zoom out to this layer just to demonstrate what we get here. And I'm going to turn off the line features, which are making this result rather busy. But you should see 3 different polygons with slightly differing pink colors associated with the distance value that I set up in the cutoff. So had I made this, instead of walking distance, walking time, I'm going to go ahead and fix that. It's going to give me 5, 10, and 15 minutes, and I'll leave that as is. Go ahead and rerun this analysis. I think we'll end up with a slightly smaller polygons here. Now it's basically following from the starting point. It's following each one of the valid street segments out to a given distance, and based on an estimated walking time or walking speed, I mean, and then 5, 10, and 15-minute time slots. So it walks from the central starting point out in all directions. And so you basically, it would be like starting at the hospital, walking 15 minutes along a street at some standard pace, and then doing that with every possible routing option from the starting point. So I'm going to zoom in on this set of polygons again. This will be a little bit more reasonable as far as a walking time goes. My system is not cooperating here. Okay, let's just do this manually. I don't know why this doesn't want to zoom in for me.
Bill, you might just want to check that your Explorer tool is activated. I don't know if that might be.
Could be. It's certainly not cooperating. Even zoom to
Yeah.
layer doesn't want to cooperate for some reason.
Mm.
I keep going back to that outstate location, and I'm not sure what's going on with that. There's my zoom tool. Okay, yeah, it looks like you were right, Molly. Thank you. Okay, so these polygons look a little bit more reasonable as far as walking times, and I'm going to turn those off and turn the lines on. And so you can see I've defined the street network that I can get to in that 15-minute time frame. And also I have polygons. So these two types of features could be used for further analysis. Maybe I want to calculate the total road distance that I could cover in 15 minutes from this hospital. Perhaps I'm interested in understanding what sort of recreational activities I have in my neighborhood, and so this would allow me to define that explicitly with an actual number. So that is service area analysis, and I'm going to minimize that and close it. And let's go back to the analysis toolbar or ribbon. And in this case, we're going to do a closest facility. So this would be an analysis like I've gotten a call for an ambulance. Someone's having a heart attack and we need to respond with an ambulance. And we can identify where that call came from. And then I have certain locations or hospitals that would be the source for that ambulatory response. And so those would be the facilities, and the incidents are going to be the locations where the call is coming from. So I'm going to go back and zoom to my familiar Forest Park area, so I can see several of the hospitals. I'll turn that layer back on. And I'm going to make sure all of my features are cleared. And then I'm going to minimize my table here a bit so I have some more real estate. And now let's go ahead and populate this closest facilities layer. So let's go to the closest facilities ribbon. This has settings that are associated with this analysis. Importing the facilities is going to be relatively simple. I want to import all of the features in the Missouri Hospital geocoded location. So I don't have anything selected on that layer. I'm just going to go to Mo Hospitals Geocoded, and that will import all of the hospitals, even the ones in outstate Missouri. Now, I will point out that this drop-down menu is also showing me routes, service areas, and closest facilities features. So the features that are listed as part of those groups are also available for my use. So if, for instance, I was performing a route layer or an analysis that was going to use the same stops that were in my route layer, I could just select this layer to load them from. And in fact, that's what I'm going to do, since I only want to work with the hospitals that are in this close region. So now we'll go ahead and run this. It's added those locations as facilities. And then obviously you can see there are some facilities outside this that were not included in that routing analysis. So they're not going to be included in this closest facilities analysis. Now for incidents, if I had a point layer that corresponded to my incident or calls for service, I could import that just like I did the import facilities, because there's this import incidents options. But in fact, I want to show you a manual way of adding features into this analysis. So for the incidents, I'm just going to highlight it, highlight that layer, and then I'm going to go to the edit ribbon. The edit ribbon allows me access to the create tool. And if you click on that, we get the create features box over here, which includes templates for all of the features that are in my contents pane. And one of those is incidents. So I can actually activate that by clicking. And now I can simply add points to my map at the locations of interest. And so you can see my cursor has changed now to this square symbol, which corresponds to the incidents. And I'm just going to pick 2 or 3 random locations and click on them to add a point at that spot. So I've added an incident here. I'm going to add an incident in between these 2 hospitals to see which one wins. And then I'm also going to pan just a bit, and I'm going to put a location down here right by one of these other hospitals that are not part of my analysis. So now I've got 3 incidents loaded. The thing you need to remember when you're using this function is you need to come up to the edit toolbar and save these edits. So we'll save those options. It asks me if I want to save all, and of course I'll say yes. And then I'm going to close my create features option. So I'll close that. I'm going to go back to my map tool and activate my Explorer tool so I don't have the edit tool associated anymore. And then I'll go back to my closest facility and the closest facilities ribbon. So now I have similar options for configuring the analysis here, drive time towards the facility. I could use some cutoff feature. This basically says I want my travel time to be limited to a certain value. I want to be able to get to this facility in less than 20 minutes or something like that. So I could set that here. I could also determine how many facilities I want to respond. Can you guys still hear me?
Yeah, you got a little softer
Okay.
in the
Yeah.
last minute or so.
For some reason, I'm
But
hearing
we
that
can
in
still hear
my.
you.
Okay, good. So anyway, continuing, you can set up the number of facilities you want to find. I'll go ahead and boost that up to 2, so we can find the 2 closest facilities in our analysis. And then, of course, we can generate output of straight lines, no lines, or follow along the network route. And we'll go ahead and do that. So let's run this analysis. Okay, and so now I've generated routes, and I'm going to open up that attribute table. Good grief. Don't know why it keeps coming to that point. I must still have some something associated with the route analysis as far as, or the geocoding analysis as far as identifying those points, because I keep going back to that hospital. At any rate, my route table has 6 lines in it. 2 of them are going to be associated with each one of the incidents. So this first one connects the incident to the one closest hospital. The other connects that incident. Oh, good grief. To the to the other hospital. Now you can see that there are other hospitals that are physically closer to this one, but it is likely a one-way street issue that's allowing it to find this other location. You'll also notice in the attribute table, excuse me, in the attribute table, there are various other parameters like incident curb approaches, facility curb approach, start time, end time, all of these other factors that can actually be calculated into the analysis and will have an impact on the results. Now, if I scroll out to the right, I do get a total travel time variable that I've compiled and a total distance in kilometers for each one of those routes. So this type of analysis would allow a user to generate a series of routes and then obviously pick the shortest one. This is the type of analysis that a dispatcher would do on the fly. A call comes in with an address, they could type the address in, geocode it to a location, and then automatically perform this this closest facility analysis to identify either a fixed location like a hospital or a mobile location like a police car or an ambulance that happens to be out on the street but has a GPS unit associated with it that would identify where that facility or where that service provider would be at that given time. Okay, I haven't done this, but I'm going to go ahead and save my project. Should have been doing that regularly. At any rate, that basically brings us to the end of the steps that I was going to cover. I'm going to stop sharing my screen here.